Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. 5-bromo-2-cyclopropyl cyclohex-2-en-ol. Parent chain, cyclohex-2-en-1-ol, cyclohexene with OH-C1 double bond between C2 and C3. Substituent at C2, cyclopropyl group. Substituent at C5, bromo. Moving on to the next step. C1 bears the OH group, enol carbon. The double bond is between C2 and C3, hex 2Na. C2 bears the cyclopropyl substituent. C5 bears the Br substituent. Numbering must give lowest locants, OH at C1 double bond at C2, C3 cyclopropyl at C2 Br at C5. Moving on to the next step. A shows Br at the top of the ring on a saturated carbon and O at the bottom. The cyclopropyl is on the carbon adjacent to Br near the double bond. This places Br at C1 area and OH elsewhere, inconsistent with C1, OH and C5. Br, B, shows OH at C1, top, cyclopropyl at C2 with the C2 is equal to C3 double bond, and Br at C5. This matches exactly. C1 is equal to OH, C2 is equal to cyclopropyl with double bond C2, C3 C5 is equal to Br, C, shows cyclopropyl at C2 OH adjacent suggesting C1, OH, double bond present, and Br at C5 but the connectivity drawing places the double bond between C1 and C2, enol at C1 with OH directly on the double bond carbon next to cyclopropyl at C2, which could fit but the Br appears at C4 or C5 position. However, careful inspection shows the OH is on C1 of the double bond but the double bond placement and Br position do not correctly correspond to cyclohex-2-en-ol numbering. D shows Br on a carbon adjacent to the cyclopropyl-bearing carbon, with OH at the bottom. This places Br at C2 area and OH at C1 but with wrong relative positions for a cyclohex-2-en-ol framework. And for the final step, OH at C1, top of ring, double bond C2 is equal to C3, cyclopropyl at C2 Br at C5, all substituents and the double bond are at the correct positions per UPAC name. Therefore, the correct answer is B. Therefore, the correct answer is option B.